Okay, imagine this. NASA wants to take a Mars rover that's just been sitting in a lab on Earth, dress it up in a spacesuit and send it to the moon. Sounds like a quick, cheap win, right? But here's the twist. Turns out, slapping a lunar upgrade on a garage sale Mars rover might cost over $1 billion. And suddenly, this feels less like a genius hack and more like a cosmic game of budget chicken. So what's really going on here? Let me unpack this wild idea and why it's blowing up the space community. /n/n let's start with the basics. NASA's plan, called Promise, would repurpose an engineering model of the Curiosity and Perseverance Mars rovers. These models are basically the cars they test drive on Earth to troubleshoot the real ones on Mars. NASA Administrator Isaacman calls it raiding the pantry, using existing tools to rush a moon mission. His argument: why build something new when you've got hardware already lying around? But here's my first red flag. Just because something's built doesn't mean it's space-ready. This rover has never left a clean room. It's like buying a showroom car and expecting it to win Le Mans without modifications. /n/n the Planetary Society dug into the numbers and said, hold up, this isn't a garage sale bargain. Their analysis says retrofitting Promise would cost up to $1.3 billion, with a launch not happening until the 2030s. And honestly, that low-end $700 million estimate still feels wildly optimistic. Why? Because slapping a Mars rover on the moon is like taking a scuba diver and dropping them on Everest. The moon's environment is brutal. No atmosphere, wild temperature swings, and that punishing dust. Mars rovers are built for dust storms and 1% atmospheric pressure, not vacuum conditions and lunar regolith that's basically glass powder. The electronics, the power systems, the mobility, everything needs re-engineering. And re-engineering isn't free. It's billion-dollar territory. /n/n but the deeper issue here isn't just cost, it's priorities. NASA's got one spare RTG, radioisotope thermoelectric generator, the plutonium-powered battery that keeps Perseverance humming. If they give it to Promise, they're burning their last match. What about future missions? Outer solar system probes like a Uranus orbiter or a Europa lander. They die on the launch pad. And here's the hypocrisy. Isaacman argues we shouldn't waste decaying plutonium, but is sending it to the moon instead of deeper space really the best use? From my perspective, this feels like a short-term PR win at the expense of long-term science. It's the space equivalent of fast food, satisfying now, but leaves you hungry later. /n/n let's talk about the elephant in the rover. Curiosity and Perseverance still need their testbeds. If you strip optimism, the engineering model, for parts, suddenly fixing the real rovers on Mars gets way harder. Imagine your mechanic stealing your car's spare tire to patch up a neighbor's bike, then getting stuck with a flat on Mars. That's the risk here. NASA's trying to play Jenga with its own infrastructure, and one wrong move could topple active missions. /n/n what's fascinating to me is how this debate mirrors a bigger tension in space exploration. Speed versus rigor. Isaacman's mantra, less debate, more wins, sounds inspiring until you realize wins are subjective. If Promise launches in 2030 at $1.3 billion, will taxpayers see it as a win when they could have funded 3 smaller missions? Or a flagship mission to Saturn? This isn't just about a rover. It's about who gets to decide the future of science. The engineers? The politicians? The bean counters? /n/n so here's my closing thought. Innovation rarely comes from playing it safe, but neither does it come from throwing darts at a parts bin. NASA's caught between a rock and a hard place. Prove progress to keep funding flowing, but don't sacrifice the science that made them iconic. Maybe the real question isn't whether Promise should go to the moon, but whether we're asking the right questions about what legacy we want to leave up there. What do you think? Drop your take in the comments. Should NASA play it safe or swing for the moon with whatever's in the toolbox?